जय जिनेंद्र बंधुओं। तो अभी हम एक तत्वार्थ सूत्र पर कमेंट्री पढ़ेंगे जो कि प्रोफेसर जी आर जैन द्वारा वर्णित है। इस कमेंट्री का नाम है कॉस्मोलॉजी ओल्ड एंड न्यू। तो ये बेसिकली 5वें चैप्टर पर कमेंट्री है 6 डाला के। तो यहाँ पे ये साहब बोल रहे हैं a modern commentary like this. A modern commentary on the 5th chapter of तत्वार्थ गामा सूत्र और तत्वार्थ सूत्र। और ये जो है प्रोफेसर जी आर जैन जी द्वारा वर्णित है। ये इंटरनेट पर अवेलेबल है फ्रीली, आप इसकी पीडीएफ को डाउनलोड कर सकते हैं। तो मैं सारा पहले का जो है स्किप कर रहा हूँ और सीधा कॉस्मोलॉजी ओल्ड एंड न्यू के पहले अध्याय से शुरू करता हूँ जो है स्पिरिट ऑफ मॉडर्न साइंस। So let's start to read and we'll try to understand in between if something is so much puzzling. This world of ours is dynamic, not static. This is true that this world is not static, is ever changing. It is ever changing and progressing in a forward or backward direction. Like the spokes of a wheel, the rise and the fall follow in succession. Jain Acharyas have divided the cycle of time into उत्सर्पणी। तो यहाँ पे एक साइकिल जो टाइम का है उसको उत्सर्पणी कहा है, and अवसर्पणी। So basically fundamentally time is cyclic nature in Jainism. Likewise also in Mayan philosophy it is cyclic. But in Jainism there are two parts of this cyclic period. One is fall and one is rise. So Utsarpani is when the time rising and Avsarpani when the time is falling with a slow serpentine motion. The rise of the sun to the zenith and its fall again every evening is teaching this great lesson of nature. So we can see that the great civilizations of Rome, Greece and Babylonia, which rose to the highest point of glory and are now non-existent, are illustrations in point. The early history of modern science shows that the great scientists like Galileo and Bruno had in their search for knowledge to face insults and suffer tortures at the hands of the blind custodians of religion. The times have changed and the present is an age of steam, electricity and electronics. The very section of society who had done its best to check the development of scientific ideas is now anxious to verify the principles of its religion in the light of modern investigations. So now everybody or every religion is trying to correlate with the science in this modern era. A word of caution may be sounded at this stage. In order to make a true comparative study of one's religion and the modern science, one should not forget the spirit of the modern scientist. The present tendency is to distort every fact of religious principle so as to bring it in conformity with the theories of science without knowing that the theories of science are not absolute truth but are ever changing. So this is very important here that theories of science are not fixed like in many religions that certain principles are fixed, but in science there is a flexibility and there is a space to correct if the previous theory was not able to satisfy certain observations. But in religion, in certain religion, not all, in certain religions, those flexibilities, those scope do not exist. The viewpoint of our study should be to collect those facts to one side which have been verified by the discoveries of science and to put forward boldly before the world those problems which do not agree with the prevalent scientific conceptions and to await solution. If one cannot explain them himself, it is a wrong policy to believe that whatever comes from the West is right. Whatever is ours is wrong. Although it is true that Westerners make inquiries with impartial views. But since there are limitations to human understanding, the result of inquiries is not always correct. So here the fundamental point is not to believe on certain kind of things. Basically, it's not about east or west or south or north. It's not about a particular person or particular community. It's about the truth. So it's not about believing a person or making a community as authority or making a religion as authority. However, the idea is to make truth itself as an authority. So it's not that whatever is coming from Eastern philosophy is not correct, but it is also that some Western philosophers or Western thinkers had critical thinking about various aspects of nature. And because of the limitations of human understanding, when people go put efforts to understand those inquiries may not necessarily always give the correct answers. A present day scientific worker does not work as a Hindu, a Muslim, or a Jain. The principle of a particular religion may be confirmed or contradicted by his discoveries. He does not care. He is a meek seeker after the truth. So here the writer is saying the same thing. The authority is the truth, independent of the person or community or whatever it is. Whatever stands the test of sane logic and is verified experiment is truth in his eyes. Science may be defined as the promotion of natural knowledge, the pursuit of truth, or the systematic investigation of the world before us. And its claim to be regarded as such is based on the method which it employs for the search of knowledge. The first step is to ascertain the facts connected with the problem by experimental investigation. For science recognizes no authority other than nature. So the same thing. Science only authorizes the truth or the nature. So the first step that we had to experimentally investigate the connecting facts. And the next step is to classify the facts in order that their significance may be better appreciated. The third essential step is the formulation of a theory or principle to explain the facts because science is empathetically not a catalogue of facts but an attempt to fit them into rational scheme. Yes, it is expected of a theory or principle that it shall be capable of experimental verification and shall lead to a search for new facts. Thus, the journey is continued ever onwards into new realm of knowledge. The characteristic feature of this method is that it is constantly in touch with experimental facts, and that is why science can justly claim to be pursuit of truth. But are the theories of science absolute truth? No, they are not. Of course not. Yes, that's true that scientific theories are not always true. Science is a series of approximations to the truth. At no stage do we claim to have reached finally. Any theory is liable to revision in the light of new facts. This is both the joy and inspiration of science that there appears to be no end to new knowledge with its interest. Yeah, that's true. In science, there is something new. People are seeking something new that they don't know. They are always trying to understand a particular thing in with several aspects. Each advance yields a more far reaching and interesting picture of the physical world, while at the same time opening up fresh views in the shape of new problems awaiting solutions. Leopold Infeld in The World in Modern Science says scientific theory is an attempt to form a mental picture of the reality which surrounds us. It may embrace either a narrow or wide range of facts and also experimental laws, bringing them into due order. Science is not, however, a collection of laws and a haphazard agglomeration of facts. Their theory, to begin with, binds them together with a common idea and creates a picture of reality from which particular facts follow by a process of logical reasoning. Theory is something more. It is a creative agent, a guide to a land of new and unknown phenomena. It shows how to evolve new systems and to discover new laws. It draws its life blood from experiments, which confirms its conclusion. Experiments which conflict with its deductions overthrow and destroy it. Experiment is and will always remain the final court of appeal, deciding the fate of a theory. So, in science, we do basically two types of uh, scientific discoveries. The process is two types. One is experimental, another is theoretical. Theoretical groups or theoretical investigators, they predict certain things, and to find out those things, certain kind of experiments are built, and if those experiments confirm the outcome of the theory is accepted, otherwise the theory is rejected. A classical example of is the uh, is the discovery of Higgs boson. Higgs bosons were discovered theoretically a long time ago, but they have been discovered experimentally recently. So the theory of the bosons, the Higgs boson, is accepted now. I mean, it was accepted, but people were trying to discover the fundamental of mass, the particle, the Higgs boson particle, and they discovered it now. All right. How do theories arise? How is our mental picture of the world which surrounds us formed and developed? Do we obtain at first a rough sketch, a faint outline, which as we proceed gains in clearness and firmness and gathers new and bright colors whilst retaining the stamp and character of the original outline? In other words, is the development of a theory merely a process of evolution, or do there occur cataclysms, great revolution, which is a short space of time transform our whole physical outlook? So we have to read it again to understand it in depth. How do theories arise? So here the question is how theories came into the mind. How is our mental picture of the world which surrounds us formed and developed? So these are the fundamental questions that how we are forming the science which is just in our head. Do we obtain at first a rough sketch, a faint outline, which as we proceed gains in clearness and firmness and gathers new and bright colors whilst retaining the stamp and character of the original outline? So at first it is a question. At first, do we obtain some kind of rough sketch of something and then we just outline that sketch and big time? we gain more clearness and we gain more clear ideas. Well, I believe the theory is based on mathematics, and when we do mathematics, we can write everything in terms of mathematics, and that's how theory progress. Okay. In the history of scientific development, we discern both these processes, the evolutionary and the revolutionary. Evolution is the outcome of the collective efforts of generation of the brilliant success of illustrious men, and of minor but useful labors which serve to amplify our theoretical ideas. It is the gradual building up of the structure of science on foundations which have already been laid. Yes, that's true. In the course of evolution, great ideas grow and mature. Theory is freed from assumptions whose extreme simplicity cramps the theory. The range of facts which the theory covers gradually widens, and the originally simple mathematical form of the theory becomes at the same time more complicated and far reaching. Yeah, that's right. We shall doubtless never succeed in understanding fully the reality which surrounds us, of course. Nowadays, we are conscious that our feeble efforts and unskilled attempts to grasp the laws of nature become constantly outstripped by complexity of the phenomena observed in the world of ours. Yes, there are many phenomena that we don't understand. Yes, as a theory develops, there may appear in it some minor flaws which may remain unnoticed in the triumphal progress of the theory, only, however, to manifest themselves more clearly and menacingly later on. Difficulties of this kind, disagreement between deductions from the theory and the results of experiment, inconsistencies, and even vital contradictions which cannot be explained away by the theory, these often contain the seeds of fresh development by making it necessary to enunciate new principle and to relay the foundation of science. Yeah, that's true. The whole idea is like this. We are a scientist developing a theory, and the theory well is not well explaining the outcome of the experiment. Then it means there is a scope in that theory. There is something missing in that theory that has to be put into the theory so that it can explain the experimental outcome. When a theory is frustrated in this manner, the ground is prepared for a scientific revolution. Yeah, like photoelectric effect. This is merely the work of one great mind. Such revolution involves the transfer of problems to a new sphere of investigation. It forces us to consider the scientific phenomena in a different light, and it lays a fresh foundation upon which we proceed to build a new and different world of physics. Yeah. We give below a typical example to show how the views of science change in time. The earth is at rest, the sun moves. So this was very famous hypothesis a long time ago. Was the view of Ptolemy. The earth moves and the sun is at rest was the view advanced by Copernicus. Which of these two statements is correct? In answer, again quoting from the same work of Leopold and Field. The verdict of classical physics is clear and definite in favor of the second statement, that is, Copernican view. Yes. Is it perhaps possible? Is it conceivable? It is conceivable that both propositions may be false. And yet, a modern physicist listening to a discussion between supporters of the respective theories of Ptolemy and Copernicus might well be tempted to a skeptical smile. The theory of relativity has introduced a new factor into science and revealed a new aspect of phenomena. It is now known that the question of deciding between Copernican view and that of Ptolemy is pointless, and that in fact the propositions of both of them have lost their significance. Yeah, here they are talking about the theory of relativity. I mean, if you will if you are sitting on the sun, the earth is rotating around the sun. And if you are looking at the sun by sitting at the earth, then you are you are at rest in the frames of earth. So from your point of view, the sun is moving. Whether we say the earth moves and the sun is at rest, or the earth is at and the sun moves, in either ways we are saying something which really conveys nothing. Copernicus' great discovery is today reduced to the modest statement that in certain cases it is more convenient to relate the motion of heavenly bodies to the solar than to the terrestrial system. The reader should carefully note down the latest viewpoint of science on this ancient puzzle. The Jaina astronomers held the Ptolemaic view with regard to the relative motion between the Earth and the Sun, and until lately, before the advent of Professor Einstein's theory of relativity, the Ptolemaic view was regarded as absurd and absolutely foolish. Now it has been proclaimed that the conception of motion of the Earth round the Sun is only a matter of convenience, rather a matter of mathematical convenience. Yes, so the Jaina astronomers has the Ptolemaic view with regard to the relative motion between the Earth and the Sun. Danton expressed a similar view in relativity and common sense. The relative motion of the members of the solar system may be explained on the older geocentric mode and on the other introduced by Copernicus. Both are legitimate and give correct description of the motion, but the Copernican is far the simpler. Around a fixed Earth, the Sun and Moon describe almost circular path, but the path of Sun's planets and the end of their satellites are complex, curly, line difficult for the mind to grasp and awkward to deal with in calculation, while around a fixed Sun, the more important paths are almost circular. So this is very important. Here are some footnotes. So some lines about Professor Einstein. Professor Albert Einstein, born in 1879, has been universally regarded as the brainiest man in the world. He started the scientists all the world over by his theory of relativity. The special theory was given in the year 1905 and the general theory of relativity was published in 1915. One interesting story is told about the explanation of relativity. Mrs. Einstein did not understand her husband's theories. One day she asked, What shall I say is relativity? The thinker replied with an unexpected parable. When a man talks to a pretty woman or pretty girl for an hour, it seems to him only a minute. But let him sit on a hot stove for only a minute and it is longer than an hour. That is relativity. However, it is not as simple as that. The theory has brought revolutionary changes in the fundamental concepts of mass, length, time, and space. It has supplied a key to the better understanding of mysteries of the universe. The size, the mass, and the shape of the universe have been ascertained with the aid of this theory. Here are some of the results. The mass of the universe is, so it will be equivalent 2.143 into 10 raised to the power 55 grams. Okay, this will be 1.01 10 raised to the power 27 light years. The number of electrons in the universe 129. Oh, well, there's so many zeros with this. So total number of digits is 80. Electron is the tiniest particle of matter discovered by modern science. So here are some very important aspects of electron. Electron is the tiniest particle and has the charge which is known as the whole charge, coulomb, and mass minus 31 kilogram. So the important point is that the electron has this mass of charge, and also the proton that is 2000 times heavier than electron has the same charge. And proton is made of quarks. It has been broken. But interestingly, electron has not been broken yet and it has complete charge. And proton has 2 by 30, 2 by 30, or 1 by 30. So how it is possible? I mean, electron has full charge but is not breakable, or we don't know with which kind of more fundamental particles it is made up, because proton has the same positive charge but is made up of quarks. So it is really a strange particle. Again, we notice that the assumption of a fixed Earth and the moving sun increases the modern mathematicians' difficulties. The calculations become awkward to deal with, and hence the Copernican view is preferred. Not that the older view is incorrect. It is well remembered in this connection the words of Dr. Schubring of Hamburg University, Germany, which he spoken on 30th of January 1928 during the course of a lecture delivered at Delhi. He who has a thorough knowledge of the structure of the world cannot but admire the inward logic and harmony of Jain ideas. Hand in hand with the refined cosmographical ideas goes a high standard of astronomy and mathematics. A history of Indian astronomy is not conceivable without the famous Surya Prajanpati. What conclusion can be drawn from the brief considerations given above? The answer, in the words of Leopold and Field, is that all theories in physics, like human life, have their beginning and their end. In the 20th century, with its enormous and intensive developments in science, they enjoy for a time the fullness and joy of life, but their life is short. Our mental picture of the universe is constantly undergoing modification and change. Since is ever giving it a new shape. Science is not a structure in which only the ornamental detail of secondary importance are changing. Such a picture of it would be not only sad and dreary, but quite wrong. Yes, the joys of creative work and the joys of scientific knowledge and of an appreciation of scientific principles and laws lie in their eternal youth and change. Change is progress, the road upwards leading through error and mistake. We change or modify theories in order to bring within their ambit an ever wider range of facts and to obtain an ever greater degree of agreement with observation. Yes, the reader may well note the great contrast between never changing laws of nature enunciated by the Jain Tirthankaras and the ever changing theories of modern science. In view of this fact, it is never wise to reject what at present seems to be contradictory against the theory of science. The science is ever sounding the bell. We are beginning to appreciate better and more thoroughly how great is the range of our ignorance. Yes, yes, ignorance has no boundary, has no limit. However, knowledge is definite. Or in other words, ignorance is infinite and knowledge is definite. So it's an ocean of knowledge, it's an ocean of things that are supposed to be known, and we know nothing. It's like a drop in an ocean. Truth is what the scientist aims at. He finds nothing at rest, nothing enduring in the universe. Not everything is knowable, still less predictable, but the mind of man is capable of grasping and understanding at least a part of creation. That's right. Then there is another important feature introduced in science by the great theory of relativity. Einstein has very beautifully differentiated between true and really true. Mhm. To quote his own words, is it really true that a moving road becomes shortened in the direction of its motion? Okay, the length dilation. It is not altogether easy to give a plain answer. I think we often draw a distinction between what is true and what is really true. A statement which does not profess to deal with anything except appearances may be true. A statement which is not only true but deals with the realities beneath the appearances is really true. So it is just the case of appearance and providing the facts. According to Einstein, we can know the truth but not the real truth or absolute truth. The following illustration taken from the domain of physics will make the point clear. Imagine a stationary conductor charged with electricity placed anywhere upon the surface of the earth. There exists an electric field around the charged conductor. It's electrostatic simple problem. In other words, it means that if any other conductor charged with electricity is brought in the neighborhood of the former, the latter will be attracted or repelled depending upon whether it is charged with opposite kind of electricity or the same kind. It is well to bear in mind that there is no magnetic field around a stationary electric charge, that is, a magnetic compass brought in its neighborhood, would not be deflected by it. But as the Earth is in motion round its axis to an observer situated on a distant planet, the conductor which is stationary relative to the Earth will appear to be in motion. Now we have just said that there is no magnetic field around a stationary electric charge, but a charge in motion always gives rise to a magnetic field. So if the distant observer were to make his measurements on the terrestrial conductor, he would find the presence of the magnetic field. It means there is no magnetic field around the conductor relative to the observer on the Earth, but there is a magnetic field around the same conductor with respect to the external observer. We arrive at the strange conclusion that the charged conductor is giving rise to and not giving rise to a magnetic field at the same time. Excellent. What is the absolute truth? Is there a magnetic field around the conductor is there none? No answer can be given to this question. Einstein says we can only know the relative truth. The real truth is known only to the universal observer. Universal observer Einstein is none else but the Almighty, Sarvajan Deva, with infinite power of knowledge and bliss. So for the simplicity, to simplify this example, let me give you another example. This is about the electricity and magnetism. But imagine that you are standing in a bus. You are standing on a road and your friend is sitting in a bus in front of you. Now, when the bus is moving, the person who is sitting next to your friend is moving with respect to you, but the same person is not moving with respect to your friend. Yes? So it simply means The truth depends from which point of view one is talking about. So, one's truth is one's perception about the life. It is the same thing with the colors. For example, the red color that I see, not necessarily all the people see the same kind of red color, because not all the people may have the same red photoreceptor in their eyes. So my perception of red may not necessarily the same as the other people perceive. Similarly, the people who cannot see since childhood may not have the same perception of red color as I or other people who can see the red color. So when we say truth, when we say reality, that is basically the perception of an individual, how an individual living being is perceiving the surrounding in normal sense. According to Einstein, even the measurement of space and time is relative, says Eddington in the nature of the physical world. A fast moving traveler lives more slowly. His cycle of digestion and fatigue, the development of his body from youth must be slowed down in the same ratio. If the speed of his travel is very great, we may find that whilst the stay-at-home individual has aged 70 years, traveler has aged 1 year. This probably furnishes an explanation of the long ages of thousands of years enjoyed by devas and of the long durations after which hunger is excited within them. It is quite possible that the Vimanas aeroplanes in which they live and move are moving with tremendous velocity relative to us. Thus, we see that the truth investigated by science is relative and not absolute, and its theories are ever liable to change. The reader might well ask, what is the value of science if it does not reveal the reality which surrounds us? How are we to discern through ever changing theory the true outline of the world in which we live? Remember that science has failed to answer these questions. Again, in the words of Leopold Ilfeld, what is the use of introducing these great questions of metaphysics into a sphere in which we are only just beginning to appreciate the immense complexity of what are seemingly the simplest phenomena of nature? Yep. Once again, we appreciate the reason not to forget the words of Professor Infield. Scientific theories arise, develop, and perish. They have their span of life with its success and triumphs, only to give way later to new ideas and a new outlook. As Sir Rabindranath Tagore, winner of the Nobel Prize, said, until I had received an honor from a foreign country, I had received scant admiration from my countrymen. So we may so we may say, until an ancient view receives recognition from a foreign country, it receives scant admiration from its countrymen. This spirit should die, and the time is come when we should prove by our independent work the truth of our convictions. The author will consider his lifelong labor amply rapid if he succeeds in some measure in establishing to demonstrate that this is so by publishing this commentary on the fifth chapter of Tatvarthsutra by Sri Acharya Umaswamy, also called Umaswati, comprising only 42 aphorisms in Sanskrit, covering hardly a page of this book. So here is the fifth sutra of Tatvarthsutra, and we will continue in our second part. We will end for now and see you soon. Jai Jinendra.